All right, now here comes the big boy stuff, conditional probability. So here, this is what we talked about last time when one event influences the other. So we have the probability of A given that B already happened. That's what our formula looks like. So this is when we divide. This is what you're talking about. We divide when we do conditional probability. Because remember, when it's conditional, we're changing our total because one thing happened, so the total probability for the second thing isn't the same. An example here is this. If I roll two die and take their sum. So what this is saying, okay, find the probability of getting a 7, the sum of 7, when the total sum was at least bigger than 5. So I first want to find out what the probability of 7 looks like, and that's why I have this whole chart here. So these are all my outcomes here when I just add them together. So for example, if I have 1 and 1, I get 2. If I have 2 and 3, I get 5. So that's what that means. Now, what I'm looking for is the probability of getting a 7 when the total sum is greater than 5. So before I use any formulas, we can just use this diagram right here. This is our sample space. So if I'm looking here, does anybody know what's the probability of me getting a 7 if the total sum is at least greater than 5? Well, the hint is here, the total sum has to be greater than 5. So everything here, if you notice, is greater than 5. So now what this is saying is, out of all of these choices that I just circled, what's the probability of getting a 7? Well, how many 7s do I have here? I have 1, 2, 3, 4, 5, 6. 6 out of how many? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So I have 26 options that I circled. So just from this diagram, it says I have 6 out of 26. Remember, 6 7s out of 26 total in the space that I circled. Everything here is greater than 5. That reduces to 3 over 13. So now, let's try to use that formula. Remember, the formula says probability of A given B equals probability of A and B over the probability of B. So first thing first, I need to find out what's my probability of this one, A and B. So look here. In this huge chart here, I can easily figure out what the probability of A and B is. So what that means, what it's asking for is, in this whole chart, what's the probability of me getting a sum of 7 and it's also greater than 5? Well, that's kind of redundant, because if it's a sum of 7, it's also greater than 5. So then it's just asking, how many times in this whole chart can you get a sum of 7? Well, if I'm looking at that, I can get it 1, 2, 3, 4, 5, 6. So probability of A and B, remember this is A, it's B, equals, it's saying it has to be a sum of 7 and greater than 5. It has to be those two. So out of 36, I have 1, 2, 3, 4, 5, 6. I have 6 out of 36. Now, what's the probability for B of getting a sum that's greater than 5? So remember, this is this part that I circled here. So remember, we counted that and we got 26. So, and this whole thing is 26. So then probability of getting something bigger than 5 is 26 out of how much total? 36. So out of 36, 26 of them are greater than 5. So that reduces to, so 13 over 18. So what does 6 over 36 reduce to? 1 out of 1 over 6. There we go. Okay. So now let's use this formula here. So A and B, we said was 1/6, right? So it's 1/6 over, and then probably a B is 13 over 18. Remember, when you divide fractions, take this bottom one here, reciprocal, multiply by the top one. So 1 over 6 times 18 over 13. That's going to be 18 over, what's that, 60 plus 18, 78. Can anybody take a guess what that reduces to?